Hi, thank you for joining my talk on Productionizing ML with Cloud AI. I'm Kaz, developer advocate from Google Cloud team. Before I start, I'd like to remind you that I'm available for chat during the talk, so as questions come up, please click on the chat button on the bottom right of this web browser to submit your questions. These are the topics of this talk. At first, I will talk about the MLOps practices that Google has been using for building our productionized machine learning system for over 15 years. And then I will introduce a product called AI Platform. That is a platform for data scientists and ML engineers for introducing the MLOps practices at scale. And then I will specifically focus on the product called AI Platform Pipelines. This will be the foundation for productionizing machine learning systems at scale. And then I will talk about the things you have to think after building your first pipeline. So let's take a look at how Google has been building their machine learning production system with their own MLOps practices. This is the word I heard from one of the long-time Google software engineer who has been building and operating one of the largest machine learning system at Google for over 10 years. He mentioned that the launching the machine learning system is the easiest part. The hardest part is keep operating that system for many years. The real problem with the ML system will be found while you are continuously operating it for a long time. So this is the famous diagram you can see on one of the machine learning papers published by Google. As you can see, the machine learning model itself is a very tiny fraction of the whole machine learning system. To build a productionized machine learning system, you have to think about many different things, like how you can collect the training data at scale, how you can extract the features from the training data at scale, how you can keep monitoring the performance of your machine learning model, and so on. So those are the challenges you will have when you are building the productionized machine learning system. But it's not just the DevOps problem. At the right-hand side, you can see all the DevOps problems like scalability, availability, portability. But not only those problems, but also you have to think about the governance of data, features, and so on. How you can build a continuous training pipeline, how you can avoid training serving skew, data validation, model analysis, fairness and explainability. Those the problems unique to the machine learning systems are tightly connected, combined with the DevOps challenges. So to overcome those challenges, Google has been learning many things and building best practices for productionizing machine learning for over 15 years. And these practices are published as the Google Publications papers, as you can see, starting from 2015. So in the last couple of years, we have been starting to hearing the new word MLOps, which is all about unifying machine learning system development with the operations practices. And when people hear the word MLOps, many people think it as how you can build the machine learning pipelines and so on. But this is just the beginning of the challenges you will face with the productionizing machine learning systems. So to apply those real-world MLOps practices to the productionized machine learning systems, we provide a product called the AI Platform. This is a platform for data scientists, ML engineers, and MLOps engineers, and so on, for building the machine learning lifecycle platform for your production machine learning system. This is an overview of AI Platform. For applications, it can be applied for a wide variety of the machine learning or AI applications such as the vision analytics, video analytics, conversational systems, or natural language processing systems, or the systems for the structured data analytics. And to build those systems, we provide the core the components such as the large-scale training or large-scale predictions systems, or the AutoML technologies, or the machine learning APIs, data labeling, and so on. And this AI platform can be shared with the multiple stakeholders, not only the data scientists, but also it could be used by the data engineers or ML engineers, or the infrastructure engineers or product managers, every people can share the same resources and platform and understand what's going on with the production systems. If you are a data scientist, maybe you can get started with AI Platform Notebook, which is a Jupyter Notebook environment running on the cloud. So the popular data science tool has been already installed, so you don't have to install your own CUDA drivers or TensorFlow by yourself. And it is tightly connected, integrated with the cloud or Google Cloud tools such as BigQuery and Cloud Data Flow. And you can choose any amount of the computing power, starting from the 1 virtual CPU up to 16 NVIDIA A100 GPUs. And also another product in AI platform is Deep Learning VM and Deep Learning Container. These are the standardized virtual machine image or container images with the popular tools such as TensorFlow, PyTorch, Scikit-learn, CUDA drivers, and so on. They support the NVIDIA A100 GPUs already, so you can get started with TensorFlow 1.15 to 2.4 or PyTorch 1.6 to 1.7. The images can be easily deployable for the notebooks. And if you want to run a large-scale training job, AI Platform Training is the best tool for you. This is a managed distributed training service where you can have the maybe tens or hundreds of the GPU nodes running in parallel. And it also supports the NVIDIA A100 GPUs, so you can have the large-scale distributed training environment without spending so much time for building your own cluster with GPUs. And it also has the state-of-the-art and automated hyperparameter tuners in it. And now AI Platform supports the various options for the training the models. Starting from the AI Platform Training, which I just mentioned, but also you can choose to use the AutoML, which is an easier way to build your own customized machine learning model for the vision or the translation models. And also you can choose to use the BigQuery ML for directly training your model on BigQuery data warehouse. All of those trained models can be deployed to the AI Platform Prediction that supports the NVIDIA GPUs for the prediction workload. For example, if you use the AutoML video for training your model, you can easily create video recognition models for classification, object tracking, and action recognition. And you can easily export that trained model to the edge use cases. For example, those models can be used for the prediction at edge with the NVIDIA T4 or JSON devices. So that was the quick introduction of AI Platform. Let's take a look at a specific product called AI Platform Pipelines for applying the MLOps practice in action. This is a quotation from one of the papers from Google. At Google, a hybrid research approach where the engineers, researchers are embedded together on the same teams, this has helped reduce the source of the friction significantly. So that means it's really hard to solve those MLOps problems by while you are having the isolation between the data science and the IT ops team. This is another quotation from another publication. Rule number 16. You have to plan to launch and iterate the training of the model again and again. And also the rule number 8. You have to understand what's the freshness requirements of your system. Rule number 9. You have to detect the hidden problems before exporting and deploying the models. So to avoid those problems and apply the MLOps practices, we provide a product called AI Platform Pipelines. This is a continuous training and deployment and experiment management systems for the entire machine learning lifecycle. And the important concept of this product is the reproducibility, audit, and governance on so-called artifacts. So not only the models you have trained, but also you have to have some auditing or the governance on the raw data or the processed features or the design pipelines or the many experiments done by the many data scientists. These are all so-called artifacts, and you have to have some governance on these deliverables. And pipelines are based on the open source SDKs called Kubeflow pipelines and TensorFlow extension. So if you want to customize any part of the functionality, you can easily take a look at the source code and put some patches on it to customize those functionalities based on your requirement. And this is one of the frequently asked questions, but the TensorFlow is not only the only framework that the AI platform pipeline supports. It also supports the PyTorch, scikit-learn, XGBoost, and any arbitrary machine learning frameworks you want. And one of the most interesting features of the AI platform pipeline is the metadata management with Lineage Explorer. So as I mentioned, the tool allows you to manage many artifacts like data or model or pipeline design and itself. So by using Lineage Explorer, you can easily track the lineage or dependency between the models and preprocessed features or raw data or the data processing components. With the foundation of AI platform pipelines, you can build your own ML lifecycle management practice, starting from the ingesting the data or validating the data or preprocessing the data, training the model, evaluating the model, and deploy the model to the prediction infrastructure. And all of those components can be tightly integrated with the other Google Cloud tools, such as BigQuery or AI platform training for the large scale training with NVIDIA GPUs or large scale prediction or data processing with the data flow. For example, Cloud Data Flow now supports NVIDIA GPUs for batch processing or stream data processing. So any large-scale preprocessing or large-scale feature engineering or prediction, you can use the Cloud Data Flow with the NVIDIA GPUs like a T4 or P100, V100 can be used for providing a powerful computation power for those feature engineering or large-scale prediction. One of the use cases of the AI platform pipeline is experiment management. In the past, many data scientists have been using the ad hoc tools such as Excel sheets or open source tool for individually managing those experiments, like what kind of the model designs they have used, what kind of data set versions they have used, and so on. But now we have the metadata store embedded in the AI platform pipeline that allows you to share all the metadata or conditions for reproducing the experimentations by anyone, not only yourself. And also AI platform pipelines allows you to build a scalable continuous training setup. And this is one of the most important concepts from MLOps, which is the CI/CD, continuous integration, continuous delivery, into the machine learning production systems. That was how AI platform pipeline works for introducing MLOps practices for productionizing machine learning systems. Lastly, let's think about what are the next problems you have to think after building your first pipeline. For example, data validation. This is another quotation from Google paper that says we want the user to treat data errors with the same rigor and care that they deal with bugs in code. So if you want to validate the behavior of your machine learning system, the one thing you can do is that validate your training data and serving data. And actually, Google Play team was able to increase the application install rate up to 2% after introducing the data validation practice. So to apply the practice of the data validation, we provide a tool called Tensorflow Data Validation, or TFDV. This is a tool for understanding and validating and monitoring the machine learning training data and serving data at scale. And actually, this tool has been used by the largest Google's machine learning systems with the petabytes of data every day. So you can easily maintain the health of the production machine learning pipeline by applying the TFDV. Let's take a look at how TFDV works. In this sample code, it starts with the SQL on BigQuery for retrieving the Chicago taxi trip dataset. This is a sample dataset with all the trip start timestamp or trip seconds, what kind of payment types they have used, and so on. And to visualize the statistics values of each features, you can use TFDV like this. So you can quickly visualize and understand how the dataset looks like. For example, if you take a look at the feature called payment type, you can understand many people are using cash or a credit card for paying to the taxis. And also you can use TFDB for comparing two different datasets with their feature distributions. In this case, you are seeing two different bar charts with different colors. So if you're seeing any decrease of the accuracy from training to the evaluation, you can check out whether there's any big changes in the feature distributions. And also you can use TFDB for monitoring the drifts and skews on production. Drifts and skews are the changes of the distribution of each features based on the timestamp or based on any different the conditions. Now let's take a look at how AI Platform Pipeline actually works inside the Google Cloud Console. From the dashboard, you can choose the navigation menu and find AI Platform and pipelines in it. So this is the console for the AI Platform Pipeline, where you can press the New Instance button to create a new instance. And AI Platform Pipeline is actually an Kubeflow pipelines running on Google Kubernetes engine. So you can press Configure and specify the attributes for creating a new instance. And if you have any existing GKE cluster, you can use that or create a new cluster and then deploy the Kubeflow pipelines on it. Once you have created your instance of AI Platform Pipelines, you can open the console and open Pipeline Dashboard by clicking it. This is the console of the Kubeflow pipelines, where you have the Getting Started documents, tutorials and demonstrations, and the other navigations menus at the left. For the first times, you can see an example pipelines already registered on the console. So you can try out some of them. For example, this one is kind of hello world kind of the pipeline, where you have the most simple design of the Kubeflow pipelines. For example, this repeat write component is just a simple component that repeats the specified the strings like hello for the specified number of times, like 5,000 times. This another simple component takes any strings as an input and just print out those text to the standard output. So if you want to try out this simple pipeline, you can click the Create Run button and press Start it. So AI Platform Pipelines runs the execution based on the pipeline you specified. After finishing the execution of those pipeline, you can check out the result of the execution. For example, you can choose one of these runs from the runs menu, where you can see the result of the hello world, the sample code. For example, if you click the repeat line component, you can check out what are the execution results. In this case, it just outputs the 5,000 hello text. And the next component just repeat that to the standard output. So there are some other interesting sample codes on the AI Platform Pipelines. If you take a look at one of them, like the TFX demonstration with the Chicago taxi sample data, you can check out the pipeline you've designed like this, where you have a component called statistics gen. This is a component for running the Tensorflow data validation, for validating the training data before start training, and you can check out the visualizations. As you can see, inside AI Platform Pipelines, you can check out the result of the visualization by the Tensorflow data validation. You can also set the threshold on the skews and drifts, so you can get some alerts when there's any significant changes on the distributions of a single feature. Another interesting component here is the evaluator, where it uses Tensorflow model analysis for analyzing the performance of the trained model. So this is a visualization by the Tensorflow model analysis, and with Tensorflow model analysis you can specify the concept called slice. It's a subset of the whole dataset for the evaluation. And in this case, the slice is set as the hour. So in this graph, you can see for the evaluation, how many the counts of the sample data it has used for getting the evaluation results. And you can also check out the other metrics, right, such as accuracy. So you can easily find out the model performance based on the timeline. So sometimes your model works so good in daytime, but you can find the performance is going down in the nighttime and something like that. So those are the features and functionalities you would get with AI Platform Pipelines. If you are interested, please take a look at the product page of AI Platform Pipelines, or you can check out the MLOps solutions page for learning what are the recommended MLOps practices you can introduce with the AI Platform products. Thank you so much.